All right, so now this is going to be a very important concept. Equivalent fractions. When can we say two fractions are equivalent? So for example, remember when we did the hexagon, we had the hexagon and 2 out of 6 were shaded, or we can look at it as 1 out of 3. So to look at equivalent fraction, let's say 1/2, and here's 2/4. They are equivalent because look, the whole is made up of 2 pieces or 4 pieces, but the same amount or same fraction is shaded. So 1/2 versus 2/4. So those are equivalent fractions. So in general, let's say I have 1 divided into 3 equal pieces, right? So I have 1/3, and the other 2 pieces make 2/3. All right, so let's have our 1/3 and 2/3 again, but take each of those thirds and break it into more pieces. So let's say I break it into 2. Well, what does that represent? It represents that I broke this 1/3 into 2 more pieces. So the top became 2 because my original 1 is now 2 pieces, but the entire whole also changed. Since I have to have equal pieces all the way across, look, the bottom, instead of 3, 1, 2, 3, is now going to be 2, 4, 6. So this is what it means to create an equivalent fraction. So in this case, we are multiplying because that's repeated addition, right? You took this and you broke it into 2 pieces. So multiply numerator by 2, denominator by 2, it occupies the same amount. So these are equivalent fractions then. 1/3 and 2/6 are equivalent. See if you can tell me what's the equivalent fraction to 2/3. I'll give you a few seconds. So here's 2/3 and here's 2/3 written in another form. What do you think it represents? So that would be 4/6. So as long as you multiply numerator and denominator by the same amount, then you create equivalent fractions. Let's do more examples. So here we have, here's my 1/3, here's my 2/3. Now, what if I broke into 4 pieces each? What do you think the equivalent fraction of 1/3 will be? Remember, this is my 1/3, and now I'm looking at this. So go ahead and write it in your notebook, and we'll pause for a second. All right? So you probably saw that it's 4/12. 4 pieces are shaded here out of 12. In the 2/3, you're going to have 8/12. So you can multiply numerator denominator by the same number and you create equivalent fractions. But now let's take a look at another way of doing it. Suppose I already had 6 pieces, so I already had 2 6. I can replace the 2 with 1 object, 2 objects, 3 objects. So again, look, the 2's became a 1. So what does that mean? I divided the numerator and denominator by 2. So just like I was able to multiply numerator denominator by 2, I can also divide numerator and denominator by 2 and keep equivalent fractions. All right, do this one on your own. So 4/12, 8/12 make equivalent fractions. So I'm replacing the 4 with this. What do you think happens? And I don't have to divide by 4. I could have also made it into 2 equal pieces. And then I would be dividing numerator denominator by 2. All right? So just remember, to make equivalent fractions, you are able to multiply numerator and denominator of a rational object. As long as both numerator and denominator are multiplied or divided by the same object, you have equivalent fractions. So in general, in words, this is how you would write it. Let A over B be any rational number and N any non-zero number. Then you can multiply. When there's no symbol, that means there's a multiplication. You can multiply top and bottom by the same number, or you can divide numerator denominator by the same number. Both will create equivalent fractions. We say a rational number is in lowest terms if and only if the numerator and denominator do not share any common factors. So for example, take a look at 1/3, which is the same as 2/6. We saw that before. 2/6 is not in lowest terms, but 1/3 is, because 2 and 6 still have 2 common in both of them. 15/10 is not a fraction in lowest terms. Why not? Because they share 5. So, however, now if I divide by 5 right here, then I'll end up with 3/2, and that is a fraction in lowest terms. So 15/10 divided by 5 is the same as multiplying by 1/5. This next interpretation we'll talk about later, but in case you know it, you'll see how it's the same. So for right now, we want you to understand multiplying numerator denominator by the same object or dividing by the same object creates equivalent fractions. All right, so let's take a look at more examples of rational objects. 3/x. Now, just like our rational numbers, again, you can multiply numerator denominator by the same quantity and get similar. All right, here are more examples. So I can multiply numerator denominator of this rational expression by x plus 1, or I can multiply both numerator denominator by 2. This fraction is equivalent to that fraction. It's also equivalent to that fraction, but also this fraction is equivalent to that fraction. Here's some more examples. Again, I can take this fraction and divide both numerator denominator by x, and I'll end up with that. A lot of people are used to saying cancel the x from top and bottom. That is not a good way to think of fractions. You're never canceling anything. You always have to think of what algebraic operation you are using to simplify. Multiplication, division, addition, subtraction. And so what we are doing here is dividing both numerator denominator by x and creating an equivalent fraction. So take a look here. I can multiply this fraction, numerator denominator, by -1, or I can multiply it by 2 plus x. All of this is creating equivalent fractions. So as long as you multiply and divide by the same amount, both numerator and denominator, you are creating equivalent fractions. This fraction is in lowest terms, this fraction is in lowest term, and this one is in lowest terms, but the others were not. We can think of fractions as decimals, like 3/40. Since we can create equivalent fractions, look what we can do. I can multiply numerator and denominator by 25. Now the bottom is 1000. And you already saw in the decimal, writing numbers as decimals, multiplying or dividing by powers of 10. We did this in the previous lecture. Since you're multiplying by 1000, like right here, that means you're taking the decimal and moving it 3 places. So you're going to go 1, 2, 3. So 3/40 is 0.075. So if you perform the division, you end up with a decimal number. So 1/2, do you know what 1/2 is? Half means 0.50. See if you can figure out why that is. So a fraction in lowest term is terminating decimal if and only if the factors of the denominator consist only of 2's and 5's. If you have anything other than 2's and 5's, then you cannot easily convert them into a decimal. You have to do something more then. All right, so see 1/3. 1/3, the denominator is 3, is not just 2's and 5's. So how do we change that to a decimal? So take a look. If you write 1/3 so that you multiply numerator denominator by 10, because 3 doesn't go into 1. So now you have 10 divided by 3 times 10. So we have 10 divided by 3, and then whatever that answer is, you're going to take that and divide that further by 10. So 3 goes into 10 how many times do you think? 3 goes into 10 3 times. 3 times 3 is 9. You're left over with 1. The division by 10 is what allows us to keep on going, and we have the number 3, 3, 3 repeating. So then 0.3 bar is the repeated decimal expansion of 1/3. Don't worry too much if the long division is giving you a little trouble. We are just introducing you how all fractions can be converted into decimals, either by long division or by multiplying by enough 2's and 5's to make powers of the bottom 10, 100, 1,000, and so on, in which case you just move the decimal point. We'll do more of long division later.